we automatically have updated timestamps on all of the database tables that we write. And now Claude knows that. So, if I ask it again to write a database migration for me, it will actually retrieve this document on database schema patterns and conventions from the Dosu knowledge store, and it'll use those patterns and conventions instead of doing its own research again. Now, what we find is, and this is just walking through what we just talked about, but I had screenshots just in case. What we find when we do this is that we actually, not only do we save tokens, so you can see here we're using, in terms of costs, only about half as much cost per run. In terms of time, around about half as much time per run. And also the variance on all of these numbers goes down. Because when Claude does its own research, well, sometimes it finds the wrong thing, you have to correct it, you have to steer it, that wastes tokens and it wastes time. It also means that run to run is more consistent as well. So what you'll find is if you ask Claude to do the same thing 5 times, you'll often get different implementations each time. And what we observe with Dosu is that 4 out of 5 runs will get the same implementation because we have that knowledge layer that's steering it towards what our standards and practices are in our organization. So, in a lot of ways, you can think about Dosu as almost like a knowledge caching layer, right? So what you can see here is essentially the effect of a knowledge cache hit on the performance of a coding agent. But we also all know that part of the problem with caches is you have to invalidate your cache. So the other piece of it for Dosu is what we call self-documenting pull requests. So that means that all of that documentation that's written into the Dosu knowledge store, every time you push a commit to your repository, it scans the knowledge that it has and asks, should anything be updated here? So if you're changing framework, adding a new interface, deprecating an interface,